Welcome to the Planet of Maths channel. In today's video, we will be solving systems of equations using the elimination method. We have here the first example to solve. Before we start solving it, we need to know what the opposite numbers are. Opposite numbers simply have signs opposite to a given number. To the number 4, the opposite number is -4. To the number -7, the opposite number is 7. Elimination method is related to these opposite numbers. We will have to look for the opposite numbers near x or y. We have 4 unknowns again. Here are x, y, x, y. And somewhere, either with x or with y, we need to have opposite numbers. Right now, with x, we have 5 and 2. These numbers are not opposites. We have 3 by y here, and here by y we have an invisible -1. And these aren't opposite numbers, so we need to get a bit creative here. We'll figure it out this way. Just like in the substitution method, we first look for a weak point of the system of equations. Here, the weak point is this y, because next to y there is no number. It means there's an invisible -1, but that's precisely the weak point. To have opposite coefficients here, it will be easier to make them with y. Here we have positive 3y's. So here at the top, we would want to have -3y's to have opposite coefficients. If I want to have -3y's here, I need to multiply the whole upper equation by 3. And I need to multiply by 3 all 3 pieces. I have to multiply this, I need to multiply this, and this. 5x multiplied by 3 equals positive 15x. Negative y times 3 is -3y's. I multiply this 8 by 3, which is 24, and I copy this second equation without any changes. Now it turns out I already have these opposite coefficients right here by y's. I have a -3 and I have a positive 3. Now I can do something like this. I underline it. I will be adding from top to bottom, meaning I will add x's with x's. 15x plus 2x equals 17x. -3y's and positive 3y's cancel each other out. These y's reduce. There are no y's at all. And on this side, 24 and 27 also add up, resulting in 51. And now I have an equation with only x. So now I divide by the number that's next to x, which means dividing by 17. And from this, I get x. 51 divided by 17 equals exactly 3. So I have calculated x already, and now I still need to calculate y. To calculate y, I can now choose any equation from above this line. It's one that seems easiest to me. It's definitely not going to be the easiest. You can choose the first option, but I'll choose the second. I'm taking this equation aside, copying it. And in this equation, in place of x, I can insert what I calculated. So, here instead of x, I put 3. The rest remains unchanged, so 2 remains unchanged. After 2, there is an invisible multiplication. So now I write this multiplication. Instead of x, I put the number 3. Here was x, now there's 3, and I'm copying the rest. Plus 3y unchanged equals 27, no changes. What now? Now we multiply. 2 times 3 is 6, plus 3y remains unchanged, equals 27 unchanged. Now, we don't want this number 6, it's not where it needs to be, thus we subtract 6 from both sides of the equation. These two numbers cancel out, and on this side, I only have 3y's left, and on the other side, we subtract these two numbers. So, 3y equals 21, and now all that's left is to divide by 3, and y will be equal to 7. Thus, the solution to our system is such a pair of numbers. X equals 3, y equals 7. In example B, we have 2 x's, 3 x's, 3 y's, and -4 y's. As you can see, there's no weak point here, as we had in example A. Now we need to think a bit differently. If there's no such weak point, we need to multiply both equations. And now, how much to multiply by? Here we have to choose either x or y. You have to make a decision. I'm deciding on y, because here I have a plus, and there I have a minus. And I want to have opposite signs. So here I already have opposite signs, just need to match the number. And if I have 3 and 4, I multiply as if I were bringing it to a common denominator. For 3 and 4, the common denominator is 12. I aim for 12, means here at the top I'd like to have positive 12y. So, to get positive 12y up here, I need to multiply this 3y's by 4. But in the process, I'm also multiplying everything else by 4. So I need to multiply this, and this. Everything times 4. 2x's multiplied by 4 equals 8x's. Positive 3y's times 4 equals positive 12y's. Negative 10 times 4 is negative 40. In the first equation, I have 12y's. So in this second equation, I'd like to have negative 12y's. Here I'd want negative 12y's, but I have negative 4y's. Thus, I need to multiply this 4y's by 3. And I have to multiply by 3 everything in sequence, meaning this, and this. 3x's multiplied by 3 give me 9x's. Negative 4y's times 3 gives me negative 12y's, and 36 times 3 is 108. And I have opposite coefficients for y. I have positive 12, I have negative 12, so this is the situation I was talking about. I underline everything, and from top to bottom I add the x's with the x's. So 8x's and 9x's together make 17x's. Positive 12y's and negative 12y's cancel each other out, the y's disappear, and that's exactly what was intended. Negative 40 and 108 give me a result of positive 68. Now I just need to divide by the number next to x, which is 17. And from that, I get that x equals 68 divided by 17, which is exactly 4. I have x calculated, just need y. I can calculate y from any equation above this line. This equation might be that I choose the one that seems easiest to me, and the easiest seems to be this first equation, so I'm writing it down here on the side. 2x plus 3y equals negative 10. And into this equation in place of x, I can substitute the number 4 right here. Here I replace this x with number 4. 2 is multiplied by 4, and I rewrite the rest. Plus 3y equals negative 10 remains unchanged. Now multiplying 2 and 4, which is 8. I don't want the number 8 here, so I have to subtract 8 from the both sides of the equation. These numbers cancel each other out, so I left with only 3y here, and negative 10 and negative 8 give a result of negative 18. To have just y, I divide everything by 3. It turns out that y equals negative 18 divided by 3 results in negative 6. So y equals negative 6, and the solution to the entire system of equations is the pair of numbers x equals 4, y equals negative 6. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.